Alright, in this video we're going to go over integration as summation of change. Alright, so a few things you've seen before. Integral sign basically means we're adding up a bunch of stuff. Alright, because that's what we've been doing when we've been taking the integral. Alright, sigma here, you should recognize that from pre-calculus. Sigma, you're finding the sum of a series. Average value, you're still adding up stuff and then dividing it by the difference of stuff. Alright, so with integration as summation of change, we're still going to be adding up stuff, just in a little different fashion. So one of the first things we need to talk about is distance versus displacement, and this is how it appears mostly in physics. In a second we're going to go over how this changes or converts to calculus. So distance is the amount you travel. All right, no direction in mind. Think of the odometer in your car. The odometer in your car shows the physical distance that car has traveled. All right. Whereas displacement is how far away you stop from where you start. All right. So here's a little crude example down here. Okay, you have your house. So you leave home, you drive to school. Say it's 14 miles to school, right? And then when school's over, you turn around and drive home. So you drive 14 miles back, right? So your total distance that you traveled is 28 miles, right? That's your total distance. Funny thing is this is actually how far I live away from school. And no, I didn't do this on purpose. All right, so your total distance is 28 miles, all right? But your total displacement, because you started at home, went to school, and came back, so your total displacement is 0. All right? Because since you went to CFAA and turned around and went back home, you're in the place you started from, so your total displacement is nothing, whereas your total distance traveled is 28 miles. Okay? So, how does this apply to calculus? Well, net versus total. Net is displacement. All right? So your displacement is simply your integral, like we've been doing. All right? So your a to b, f of x dx, whatever your answer is, that's your displacement. Here's an example. Here we have a sine curve. All right? If we were to integrate this from 0 to 2 pi, our integral would equal 0. Correct? So our total displacement here is nothing because we have just as much above as we do below, because this is going to be a positive area, this is going to be a negative area. Since these two areas are equal, it's going to cancel itself out. So your displacement here is going to be 0. But your total distance, all right, your total distance, when you take your a to b, it's the absolute value of your function dx. So here's your sine curve now, but instead of this part being below the axis, it's now been flipped to above the axis, so now both of these are positive. So your integral will not equal 0, it will equal some number. Alright, it will equal some number. So that's the difference in calculus between displacement and distance. Alright, you have net and total. Your net is simply what we've been doing. Your total is the absolute value of what we've been doing. Alright? Now, your total, that's the wrong color. Now, your total must always be greater than or equal to your net. Alright, your total must always be greater than or equal to your net. Alright? Let me show you an example to help explain that a little bit. Well, we can go back to here. Okay, because it says your total, which is distance, must always be greater than or equal to your displacement, which is your net. So here, your distance traveled was 28 miles, but your displacement is only 0. All right? But now, if you didn't drive home, if you stayed at CFAA, your distance and displacement would both be 14 miles. All right? So your total must always be greater than or equal to your net. All right? Must always, always, always. Make sure you write that down. Let's look at an example here. All right, say your velocity is given by v of t equals t minus 2 quantity squared from t0 to t equals 4. Find the net and the total distance traveled. Did the object ever change direction? Now, position, velocity, and acceleration. Okay? Your position function you can think of as its first. You take the derivative of position, you get velocity. You take the derivative of velocity, you get acceleration. And of course, if you go backwards, if you take the antiderivative or the integral of acceleration, you get velocity. And if you do that to velocity, you get your position. Okay? But we really don't need that for this question. So, the first thing is what is the net? All right, if you remember, your net is just simply your integral like we've always done. From 0 to 4, t minus 2, quantity squared, dt. All right, you do your integral. I know you know how to do that. This comes out to 5 1/3. All right. B wants to know our total distance traveled. Well, we're going to take the integral from 0 to 4 of the absolute value of t minus 2 squared dt. All right. And again, I know you know how to take the integral. But this as well equals 5 1/3. Okay? So as you can see, they're both equal. 5 1/3 equals 5 1/3. So we found our total, we found our net, we found our total. This is the net, this is the total. Did the object ever change direction? All right. Well, since the net equals the total, there is no change in direction. All right? So did the object change direction? No. Since net equals total, there was no direction change. All right? Since the net equals the total, there was no direction change. We did not change direction. All right? We did not change direction. Okay? All right, let's look at one final example. It says a car has a velocity given by v of t equals 2 minus x. Find the net and total distances traveled from 0 to 5. If the initial position was 10, where is its final position? So again, let's start this out. A is our net. Our net is from 0 to 5 of 2 minus x dx. Take the antiderivative, you get negative 2.5. That is your net. All right, negative 2.5. B, you take the absolute value from 0 to 5 of 2 minus x dx. You take that integral, you get 6.5. So that's your total. All right, now C. If the initial position was 10, where is the final position? All right, so to get the final, you do the initial plus the net. All right, so our initial was 10, and we're going to add that to our net, which is negative 2.5, and get 7.5. All right? So, that is our final net. Alright, so this has been your summation of change video. You can watch this as many times as you need to. Make sure you come tomorrow ready to work some problems. See you tomorrow.